Saxon Algebra 2, Lesson 22. We really only have one topic for this one, with just a very brief PS on another topic. What we're going to do is we're going to start talking about our dirt problems, distance equals rate times time. And you remember we had several varieties of these that we did last year. We're going to start by reviewing type 1, which you'll recall I called the Lord of the Rings type. Because in these problems, we have someone going on a trip, and either someone goes with them, like their faithful Sam G, that's Frodo, that's Sam, or we can look at it as Sam and Frodo go to Mordor, huck the ring in, and come back home. Okay? In either one of these metaphors, the length of the trip is exactly the same. So we say that the first distance is equal to the second distance. And we can say that about both of them, so I'll draw them on both of them. Okay? Once we have the picture, we can see very clearly that we're starting with the idea that the first distance equals the second distance. Well, that D went a little out of control, didn't it? You have to send me back to first grade so I can practice those somewhere. Okay, that is clear from the picture. Then we take into account the fact that distance is always equal to rate times time. So then we can say the rate of the first trip times the time of the first trip, substituting in here, is equal to the rate of the second trip times the time of the second trip. Make sense? This gives us a base equation that we can work with. Now we can go to the problem and start finding which of these variables we have, and then we'll solve for what we don't, right? So, excuse me. Let's take the first example. How many are there? It's always good to know. There are 2. Easy. Example 22.1. Ready for the story? Roger made the trip on Sunday, and Judy made the same trip on Monday. Roger traveled, okay, blah, blah, blah. Before I get into the numbers, let's just draw our picture. Roger made the trip on Sunday, and Judy made the same trip on Monday. So this is, that's got to be the same. This is the distance of Roger, and this is the distance of Judy. And they're the same. So we can say the distance of Roger equals the distance of Judy, and then we can substitute in the rate of Roger times the time of Roger equals the rate of our friend Judy times the time of Judy. All right, now we have a base equation, good to go, and we're ready to start gathering information on this. Roger traveled at 12 miles per hour. All right, that sounds like the rate of Roger equals 12. Judy traveled at 20 miles per hour. The rate of Judy equals 20. She's clipping. So her time was 2 hours less than Roger's. Ooh, the times are crazy because he tells them to us in relation. So the time of Judy was less than the time of Roger. I write it as an inequality first because it's confusing. Her time was 2 hours less than the time of Roger. So that means if I want their times to be equal, I'm going to have to subtract 2 from Roger. Now they're equal. Okay? It's Judy. These are tricky. You know how it is when John gives us the things relative to each other, but they're less than or greater than. We've been through that. Just be careful with these. Now we're ready to plug in. Are you good to? And then it says, how far did they travel? Okay, I'll come back to that. That's a tricky question. Let's plug in what we can. Here's our base equation. I'm going to set up my buckets. And I know that I'll fill in 3 and then the fourth one will just be the variables again. The rates we've got, rate of Roger 12, rate of Judy 20. Time of Judy equals this thing, TR minus 2. And then this one I don't have anything for. And once you get that straightened out, these two letters should match. If they match, you know you did it right. If these are different, go back and check your work because something went amiss. All right, we filled in. Now we're ready to start solving. This is going to need a distribution. So 12 times that equals 20 times that minus 40. Okay, I like it. What do I want to do next? Well, I've got to get the TR fish on the same side. I could, if I wanted to make everything positive, I'd have to jump the 40 over and then the 12 over. That sounds like too much work for a Sunday night, which is when I'm doing this. So I'm just going to make some negative numbers and live dangerously. I'm going to subtract the 20 TR, sending the TR fish this way. That cancels. I get negative 8 TR equals negative 40. Well, the numbers turned out cute, didn't they? Divide by negative 8, and I get the time of, what's his name, Roger, equals 5. And then time of Judy is easy to figure out. 5 minus 2 equals 3. All right, I like it. Now, back to solving the actual problem, though. John's question is, how far did they travel? And I'm confused by that because I've got rates and times. A rate is not a distance. It's how fast you went. It's a speed. And the time is not the distance that tells how far it is. The distance equals the rate times the time. So in order to actually solve this problem, I have to multiply the rate times the time because it wants to know how far they went. It wants to know this distance from start to finish for either of them. But how do I know which one to use? Roger or Judy? Spoilers, since the trip is the same, then I can use either one of them and it should work out just fine. So let's start by using Roger. I'm gonna flip. Well, no, you know what I'm gonna do? This is my new trick, you guys, when I run out of room but I don't wanna flip the page. I keep this notebook nearby that has little paper and I just yank out a page, rip the little things off because, you know, I'm not a heathen. And then I just use this to finish the calculation so that I don't have to flip away. All right, so let's start with Roger. And we want to do rate times time, right? Because that will give us the distance. So Roger's rate is 12 and his time is 5, right? I'm just pulling from my answers here. So that tells us that it should be 60, and then we have to look back at our problem. Miles per hour is how the rates are stated. So this must be miles. And let's try it for Judy and see if we get the same answer. Judy's rate is 20, and her time was 3 hours. So that is 60 miles. Oh my gosh, it's the same. So either person, we can take the rate and the time for either person and get the same answer, which is correct. I'm just boxing one of them because we don't need to show that they're the same. How far did they travel? 60 miles. Happiness reigns in the order of the universe. Is it coming back to you ever so slightly? Fabulous. The next one introduces us to one more wrinkle in this process, and then we're done walking down this particular form of memory lane. All right, Brer Rabbit hopped off toward the briar patch at blah, 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 10 kilometers per hour at 10 a.m. Clock times. Remember that? We'll figure it out. Oh, excuse me. At noon, Brer Wolf began the chase from the same starting point. If he caught Brer Rabbit at 2 p.m., how far did he run? How fast did he run? Okay, so what is going on here? We've got a rabbit that is running through the briar patch, as rabbits will. And then we have a wolf, for heaven's sake, that chases him and eventually catches up to him. So this is another example of our Lord of the Rings style problem. We've got the distance of the rabbit and the distance of the wolf. And in the end, they're the same. I can only think, I mean, a wolf doesn't usually catch a rabbit with a catcher's mitt or a butterfly net. They would catch them with their teeth. So this story takes an ugly turn unless, you know, there's some sort of evidence here I don't know about. But wolves are not usually, you know, he's probably not chasing him to have a conversation. So, poor rabbit. All right, so we know that this is the type. And so we know that the distance of the rabbit is equal to the distance of the wolf. And then we substitute in, reminding ourselves that distance always equals rate times time. Rate of the rabbit times the time of the rabbit equals rate of the wolf times the time of the wolf. This is our base equation, which you've been seeing in other problems, right? Because you've been practicing this solving system this year, plus you're used to it from last year. So now we're ready to find these. And remember, I like this time of the rabbit, time of the wolf. You can write these in any order. I did the rates first and then the times first. Sometimes I do like the rabbit's rate and time, the wolf's rate and time. It doesn't matter as long as you keep the numbers straight. All right, let's fill things in. The rabbit hopped off toward the briar patch at 10 kilometers per hour. So the rate of the rabbit is 10. I forget about units until I get to the end. At 10 a.m. Okay, so now we need one of these clock charts, don't we? And remember how they work is like this. We got the rabbit and we got the wolf. We have a starting time, we have an ending time, and then we'll have the number of hours. I'm going to write that out for you this time. But we can use the abbreviation from here on in. No need to break our wrists over words in our math lessons. All right, so the rabbit started at 10 a.m. And I like to put in at least the A because sometimes these chases last a long time and we end up getting PMs mixed in with our AMs. At noon, Brer Wolf began the chase. Okay, so he starts at noon from the same starting point. If he caught Brer Rabbit at 2 p.m., okay, so the ending, I'm sorry to say for both of them, is 2 p.m. How fast did he run? Okay, so this is the one we're trying to find out, the rate of the wolf. So can we figure out the times of these little critters? Based on the information we filled out, we can easily see that the rabbit was running for 4 hours. That's a long time for a rabbit to run. And the wolf was running for 2 hours. So now we can plug those in. Time of the rabbit is 4, time of the wolf is 2. And now we're ready to go up here. Buckets in place of variables. Filling in, the rate of the rabbit is 10. Time of the rabbit is 4. I'm careful to make sure I'm grabbing the right variables. That's why usually on this list, I put them in that order so that I can just go down and fill across. But I didn't this time, so I just have to be careful. Rate of the wolf, we don't know. And time of the wolf, 2. Now I will multiply and simplify this. And we see that the math in this part is just deliciously easy, right? So the rate of the wolf equals 20. Let's see if that's what we were supposed to find. If he caught Brer Rabbit at 2 p.m., how fast did he, the wolf, run? There's our answer, the rate of the wolf. We need a unit on it. This seems to be kilometers per hour, and that's the right answer. All right, so this one had drama because we had to make the clock chart, but once we got that done, solving the base equation was pretty flippin' easy compared to what we've seen in the past. All right, this stirs to jog your memory on this first type of Lord of the Rings style to there and back distance problems. We will review the other two soon. get excited, get pumped, because I really love these, and I know you do too. Okay, that's lesson 22. Goodbye, my students.